All right, y'all ready? You ready?
Yeah.
All right, class.
Yes.
That was kind of weak. Seriously, that was weak soup. Come on, sing it for me, Danny. Sing it. Class.
Oh, hold on, Pastor. You can chill with that. Yeah, that's too much.
That's too much. All right. Okay, so what example are we left on?
Four, three.
Three? Okay, so let me go there. Right here? Yes?
Yes.
Okay, so now we're going to verify this. But when we verify it, if you notice, we have a cotangent x and a sine of 2x. So 2x represents a double angle. Right there on top. Kevin, come on, you had one job. Make sure everyone has the notes. Come on.
Yeah.
How dare you? Anyway, so we have a double angle and single angle here. So I'm going to convert everything to the same type of angle. So I'm going to convert this into a single angle. So I need to go back and try and find what is the sine of a double angle turn into. So let's see. So sine of a double angle turns into 2 sine A cosine A. And we know cotangent. What does cotangent represent? X over y, doesn't it? X over y. So I'm going to rewrite it, but because I'm still dealing with the double angle, I'm not going to change it into x's and y's yet. Okay? So I'm going to change cotangent. If it's x over y, isn't that cosine over sine? There we go. Times, now sine of this double angle, we said that's going to be, what was it? 2 sine? Yeah, 2 sine A cosine A. And my A in this case is going to be an x times cosine x right here. And now I'm going to put all this over 1, just so I could show what this is going to do. Because this is not in the denominator here, but I need to show where it's going to end up at. All this is numerator, and it's over 1, because eventually, what do you see here that's going to help me out? Sines. What about the sines? I could cancel them, right? Because I have a sine on bottom and top, so I could cancel those. So I'm going to get to that eventually. But that's the reason why I wrote it as over 1. Equals 1 plus. Now, the cosine 2x needs to change also. But I'm not going to do this one yet. I'm going to try and clean up the left side first. Because when we look at this, we want to verify an identity. I want the left side to be equal to the right. The reason why I'm not going to do cosine, because if I look at my identities for cosine, I have 1, 2, 3. So I want my left side to match one of these, but let's see which one I wanted to match first. So I'm going to go through and clean up my left side of my equation before I'm going to do that problem. So we said that the cosine, the sines are going to cancel here. So sines cancel. And now I have 2, right?
Yeah.
I have 2 on top times cosine. And it's cosine times cosine, which is going to give me cosine squared, right?
Yeah.
There we go.
Over 1.
Yeah, it could be over 1. Not necessary to be over 1 in this case, because I don't need the fraction right now. I needed the fraction up here because I had a numerator and denominator. So right now it just comes out to be 2 cosine squared x. All right. So now from there, I could look at the cosines I'm going to use. So all I have is a cosine squared. So am I going to use this first one right here? Say no.
No.
Because this one has a cosine and a sine, isn't it?
Yeah.
This one over here has a sine squared but no cosine. So it's not gonna make this one look like the cosine. The only one I could use is right here. That's the only one I could use there. So 2 cosine squared a minus 1. So now I'm going to turn this one into parentheses 2 cosine squared x minus 1. I put in parentheses right now. Now let's go ahead and clean this up. So I'm going to bring down. What's going to happen to this positive 1 here and this minus 1 over here? Yeah, they're going to cancel out, so they're going to go away. And so since those go away, this and this go away, I'm going to be left with just 2 cosine squared x. My left side is now equal to the right side. Now, so you guys now understand the reason why I waited on the cosine? Okay. Anyone questions so far? Yeah.
What if you do like the X line?
X minus 1, like this right here, cosine squared x minus 1.
Yeah.
So if I'm looking right here, this is 2 cosine, but in my problem, squared x minus 1. So all I did is I replaced the a, because that's whatever angle they're referring to. And in my problem, my a is an x value, and then it was just minus 1 after that. Make sense? Okay. All right, anyone else? All right, let's keep going. Now, it says simplify each expression. So pretend like I didn't write this answer right here. Because, yeah. So cosine squared 7x minus sine squared 7x. Insert page. It wasn't 2, was it? It was just cosine squared, right? 7x minus sine. All right, so now I'm going to put parentheses around this because that's going to be my angles that I'm referring to. Now, let's go through and find the formula that goes with this. So cosine squared minus sine squared. So we have cosine squared minus sine squared. That's what I have right here, right? Now, I'm going to work this one backwards. So whatever this is, in both of these angles here, it's going to go over here now. It's going to turn into cosine of 2 times whatever that angle is. 2 times whatever that angle is. 2 cosine, no, wait, dang it, why did I do that? I was so focused on 2 times. So cosine of 2 times whatever my A, in this case my A is 7x, right? It's 2 times whatever those are. So if I put that together and clean this up, 2 times 7 is going to give me 14, right? Cosine of 14x. So this is one that I'm working it backwards. Questions, concerns, complaints? Should I write that down? Okay. Are you gonna forget about it later? All right. Sine 15, cosine 15. Now, this, it's almost like my formula, isn't it? It's almost like the formula. So this is almost like my double angle of sine because it's sine times cosine, right? So I'm going to write down the formula for the sine. So it's going to be a sine of 2, is it A on these notes? Yeah. Equals 2 sine A cosine A. Did I write it down correctly? Okay, good. Now, is everyone okay with what I did? All I did is I just copied down the formula that I have. I got to look to see what information I have. What information I have. I only have sine times cosine. So what am I going to do to this over here to make it into only sine times cosine? Yep, divide by 2. So we're going to make my notes work for me. I'm going to make the formula work for me. So now if I divide this by 2, bam, bam. So now, I now have sine 15, because that's going to be my A value here, right? Times cosine of 15. So I have that. So now I'm going to plug it in over here to what it's supposed to be, because I changed the formula a little bit just to make it able to plug in. So that's going to be sine of 2 times my A value is 15. And this is going to be divided by 2. Does that make sense or is that nonsense? Questions? If you got questions, please speak. Or forever hold your peace. Yes? Good? Hey, Aaron? You good? All right. So what is 2 times 15? 2 times 15. 30. Okay. So it says sine of 30 divided by 2. Now, what is the sine of 30? So on my unit circle that you don't have to reference every single time because I had you guys try to remember it. But if you need to, go ahead. Sine of 30 is 1/2. So it's 1/2 divided by 2. And I got fraction over fraction here, don't I? Fraction over fraction. So I'm going to put 2 over 1 to make this a little bit simpler. And whenever, Yeah, because this is still 2, right? 2 divided by 1 is still 2. Now, I'm going to take it, since I have fraction over fraction, I'm going to turn it into a multiplication. So it's the top, which is 1/2, times the reciprocal of the bottom. So if I flip over the bottom, that gives me 1/2. And then 1/2 times 1/2 is 1/4. Is that good? Yes? Hopefully? Maybe? Questions? Concerns? Man, you guys are awfully quiet. Is it still too early in the morning? You guys need coffee or something? Yeah. So, all right. Sucks for you. Anyway, so that is example B. So they did it differently. I don't like the way that they do it. So that's why I did it myself. then example 5 is the last one, right? No, there's 6. I'm not doing 6 though.
7. There's 8.
Okay. So what I'm going to do now, I'm going to pause now. Actually, let's do this one. Then we'll do the last two. After a break. Okay? Break, start working on some of this. So write sine 3x in terms of sine x. So what we're doing here is we're trying to break this up. So if we currently break this up into sine 2x plus x, right? Is that still 3x? Okay, good. But now, if I only want it in sine, let's write this out first. So using my addition formula, it's going to be sine of 2x cosine of x plus sine of x times cosine of 2x. I'm using the addition formula. The addition formula for this. It is on the reference sheet if you got lost. So now, let's go ahead and take this sine 2x. This sine 2x right here, which is now kind of isolated, so it's just this piece right here. I don't want cosines. I don't want cosines right now, so what I'm going to do is I'm going to replace this with its identity to make it into a single angle. So the single angle is the sine of 2x is equal to 2 sine x cosine x. I'm going to use that. So every place that there's a sine 2x, I'm going to replace it with that. So now this one turns into 2 sine x cosine x times cosine x plus sine x. Now that brings me to this. If I don't want cosines, and I have 3 different options for this, for the cosine, for the double angle for cosine, I have 3 different options. So which one do you think I should use if I don't want cosines? Probably the one with the sine, right? Okay. So I am going to change this out, and this is going to be replaced with my 2 sine squared x minus 1. Did I write that correctly? Nope. I wrote the wrong one. So 1 minus 2. There you go. Let me clean that up. So it's 1 minus 2. I always get those mixed up. All right, I'm going to do a little bit of cleanup here. So this cosine x is being multiplied by all this, right? Yes? Good. So that means it's going to be multiplying. So if I'm multiplying a cosine here and a cosine here, that's going to give me 2 sine x cosine squared x. So it's going to turn into cosine squared, right? Plus sine. Now over here, since I have a binomial, I have a 1 minus 2 sine squared. I have a binomial here, so I'm going to distribute. So I'm going to multiply into here. So sine x times 1 is just sine x. And then sine x times negative 2 sine squared is going to be a negative 2 sine cubed x. Yes? Okay. Now, time to clean up. So clean this up. Does every single one of these have something in common?
Yeah.
What do they all have in common? A what?
Wait, yeah, X.
That's the angle that they're using. So yes, they're all going to have the same, but because that's like, it's like saying sine of 15, cosine 15, 15, 15. So do they all have something else in common? Because I can't just say that X is the common part. You got to say the whole thing. Kind of like a Tribe Called Quest. You got to say the whole thing. Or a pimp named Slickback. You got to say the whole thing. So do they all have signs? Sign, sign, sign. So you could say that you saw the signs. And did it open up your eyes? Now you saw the signs? Wow. Okay, I'm stretching on that one. Okay, so too old, too old. Anyway, if they all have the same thing, I could factor that out. So I'm going to take out a sign of x parentheses. So if I take it out of this right here, I still have a 2 cosine squared x, right? Now, plus, I took out a sign, didn't I? So if I divide sine x by sine x, what do you get? The one thing that you cannot forget? 1, right? Okay. Now over here, minus 2 sine cubed. Does that have a sign? I could take out one of them. So it's going to be a sine squared now, x, because I took out one of those. I know this one seems kind of crazy, right? Because some people are already falling asleep or zoning out. Only one. So which is it?
Falling asleep.
Oh. But you were zoning out.
No, it wasn't. I'm paying attention.
You're paying attention? Okay. All right, so anyone see anything special there? What's left over?
Oh, isn't that like when that thing?
There is one thing that you could actually should be able to notice from here. Hmm?
No, they're the exact.
That's
They're the
the one
exact
minus.
same, but they're not the same. You know what I'm saying?
They're the exact same, but they're not the same.
Yeah. So the 2
Yeah.
cos squared x and then the 2 sine squared x.
The one minus two sine squared x is just cosine 2a or whatever. You know what I'm saying?
Are we gonna distribute them?
I don't know what I'm supposed to
Hmm?
do.
No, we factored it out.
Yeah.
Okay, so now let's look. I don't want a cosine, do I?
No.
Okay, what can I replace cosine with? Pythagorean identity.
Bro, what? Which one?
Oh, it's one of them ones.
So if I have sine squared plus cosine squared equals 1, and I don't want cosine, do I?
No.
I don't want cosine. So what could I do with that? I could subtract sine squared x, right? Minus sine squared x. And what's left over here on the left?
Cosine.
Cosine squared x equals 1 minus sine squared x. Kind of like what we did before, where this is actually x squared is equal to 1 minus y squared. I know it's been a while since we started doing this, so, and I have thrown a whole bunch of formulas out there for you. But yeah, we're going to use this because I don't want sines. So 1 minus sine squared x is going to replace that. So I'm replacing this. So now there's no longer any cosines.
Yep.
So the first thing that we did on here is we had to start by getting rid of double angles. That was a problem. But since we're trying to get everything in just sines of a single angle, I took care of the double angles, and now I take care of the cosines. I'm going to distribute this piece now. Sine of x parentheses. So this 2 times 1 is going to give me 2, right? Now, multiply over here, I get minus,
2 sine squared x.
right?
Yep.
Plus 1 minus 2 sine squared x.
Oh boy.
What's going to happen to my 1 and my 2?
They're gonna like combine and stuff.
Yep, I'm going to combine them. So now it's going to turn into sine x parentheses 3 minus 4 sine x squared. Why is that 4?
Because you got 2 of the same one.
Yeah, -2 and -2.
Yeah.
So, yeah, it isolates down to this. It could have isolated down to other things if I used different values. There was only one value for the sine double angle, but the cosine double angle, it would have worked out differently. I could have used, instead of just saying I wanted 1 minus 2 sine squared, I could have used a cosine squared also. And just simplified it out when I'm done. So when you do these problems, your answer is going to be slightly different, but they are going to be equivalent. There is not too much of this in the homework. There is some, but this is one of the crazier ones. So like I said, I'm going to pause here, and I want you guys to start. Alrighty then. So we're going to finish up our notes. So looking at the example here, example 6, all this is plug in the values. I believe you might have one of these on the homework, and remind me which one it is. I will take that one off the homework, because yeah, all it is just basic algebra. Plug in this number and plug it into the calculator. So whatever V is, you just plug in that number. So don't worry about that. Now, product of some identities. So they're going through and trying to rewrite these as a different identity. So now I have two different angles. So I have an A and a B. So sine A times cosine B is equal to 1/2 times the sine of A plus B plus the sine of A minus B. And then the other way is cosine A sine B. So it could be the same thing, but it could be written as this instead. Because whatever the angles are, it's another way of rewriting this. Does that make sense? Yeah? Okay. So they're both the same thing, because if I were to rewrite it as sine and cosine, because A and B are just two different variables, two different angles. And I just work it out like this. It'll make more sense here in a moment. So here is the 4 different ones. You're going to have to reference this. So if you're going to draw like little hearts and highlight and all that all over this, now would be a good time to do that. Right, 4 cosine 75 sine as a sum or difference of two functions. 4 cosine of 75 times sine of 25. So there is a cosine and a sine. There is a cosine and a sine. So it's not this one. Not this one. Okay, I'm going to use this bottom one here because it's already put together like I want it. So I'm going to use this bottom one, cosine, sine, like this. But what's different about mine? Anyone? What's different about the one I have?
Oh, you're just 4 cosine?
Yeah, mine's a 4, right?
Yeah.
And so what could I do first to try and make it look exactly like this? What could I do to the 4 to make it look just like this? I could take it out. How am I going to take that out? Yeah, I'm going to divide both sides by 4. So by doing that, I'm going to say I'm going to divide this by 4. And over here, it's going to be equal to, I have my, let's see. So dividing this by 4 is 1/2. And it goes bracket. And it was sine A plus B of A, which is 75, plus B, 25, minus sine of A, 75, minus 25. So if I'm dividing this by 4 over here, what am I doing to this side also? Dividing it by 4. But I'm going to make the math a little bit easier. So if I'm going to divide by 4, I'm going to say there's a 4 on the bottom right here, right? Isn't dividing by 4 the same as multiplying by 1 over 4?
Yes.
Yeah. So I'm just going to leave it as 1 over 4 times the 1/2 right here. Because this is going to end up multiplying at the very end anyway.
So can we do that to 1/8?
Yeah, I'm going to.
Oh,
I'm going to. So yeah, so by canceling this out, I have now moved the 4 over to this side, and so I have the cosine sine like I have here. Now, let's go ahead and start putting stuff together now. So 1/2 times 1/4 is 1/8, right? Okay, bracket is the same thing. It means the same thing as the parentheses. And that's going to ask for the sine of 75 plus 25. What is 75 plus 25?
yeah,
100 minus sine 75 minus 25.
Oh, 50.
So I could leave the 1/8 out here, or I could distribute it in, but that's what it comes out to be. So it's a sum or difference of two functions. So now I have this function here, this function here.
And it's a difference.
Yep, it is a difference because there is a minus sign. Yep, minus sign.
That's it? You don't got
Yeah.
anything else? Okay.
Not-
That would be like, oh, if you have to find sine of 100, that ain't a thing on the thing, so.
Yeah, so yeah, what hopefully it's not too crazy.
Yeah, not so too good.
I'm trying not to be too crazy. Trying. Doesn't mean I'm working.
Patrick, have you ever killed someone?
So this one, it's sine A plus sine B, sine A minus sine B. So these are sum to products. So cosine A plus cosine B, and then it comes out to be all this. So I have to just decide which one I'm using and match with my formula. Sine 2 theta minus sine 4 theta. Okay, sine 2 theta minus sine 4 theta. Sine 2 theta minus sine 4 theta. So right here.
Yes.
Sine minus sine, right? So I have my A and my B, and then I'm going to combine this, and it's going to end up becoming 2 cosine of A plus B divided by 2. My A is 2 theta plus B 4 theta, and that is divided by 2. Is that making sense or am I nonsense right now? Still good?
Yeah.
All right, so the next part is, again,
Sine.
now it's sine of a minus b.
over 2.
So this is a times sine,
Oh, the whole thing.
I know.
Are you still recording?
Yeah,
Okay, that's gonna be like a gem to when I go watch it back. After you killed him. That was gonna be. That was a good one. Yes.
you ready?
Yes.
Okay, let's keep going. So now we could combine on the inside. So 2 theta, 4 theta gives me
6 theta.
divided by 2.
3 theta.
So cosine, 2 cosine of 3 theta times sine of 2 minus 4 is going to give me
Negative
2 divided by 2.
Negative 1 theta. Or just
Negative 1
right?
theta or just negative theta. There we go.
That's it?
Yeah.
Oh.
It's a product, multiplication, of 2 different functions.
So like you can say like product, sum, anything like that. And you
Yeah,
just add
sum
it
would
to
mean
one.
you're adding in between.
Yeah.
Difference means there's subtraction in between. This one's product, so that means there's a multiplication between.
So when you have it to like that point where it's like 2 functions, they're being multiplied by each other, like you're done. Like when you hit that point.
It's going to say what to do.
Yeah. Okay. Cool.
So sum to product, so your end result has to be a multiplication. All right, hopefully that made sense.
Yes.
Okay, make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my store.